Hey everyone, welcome back to the Physics 30 Unit 2 videos. In today's lesson we're going to be looking at centripetal acceleration and centripetal force. And so first we're going to talk about some factors that affect centripetal acceleration. So in order to discuss the factors that affect centripetal acceleration, we first need to go over the equation for centripetal acceleration. So your formula is your centripetal acceleration, so A with a subnode of c, is equal to the speed squared divided by your radius. So AC stands for the centripetal acceleration, and remember your units for acceleration in these cases should be in meters per second squared. V is the speed, or if you're given velocity, it should be the magnitude or the size. And your units there will be meters per second, and R stands for your radius of the circle, which your units there should be in meters. So from this equation, we can see that there are two factors that affect centripetal acceleration. So the first one here is this rotational speed. And then the other factor here is the radius. So if you increase the rotational speed, you would actually increase the acceleration. And this we would know is because when we're working here with a fraction, if you increase your numerator, you're increasing the actual value of that fraction. So if you increase your speed, you're increasing your acceleration. So on the other hand, if you increase the radius, so if you're making your denominator larger, then your acceleration is actually going to get smaller. And that's because we're increasing the denominator, which means that we have to break it up into larger pieces, meaning that overall our value is smaller. So if you increase the speed, your acceleration is increased, and if you increase your radius, then you will decrease your acceleration. Alright, and so please note that the mass does not actually affect your centripetal acceleration. So notice here that our variables here are speed, and if you guys remember your equation for the centripetal speed there, or your rotational speed, that was equal to 2 pi r divided by your period. So notice here there's no mention of mass here, and then radius is just that distance from the center to the outside of that circle, or that the way that it's traveling. So there is no impact on the mass of your object. Okay, so it really just has to do with your speed or velocity, your radius, and then say for even looking kind of deeper into the speed equation here, it could be your period as well. So let's do an example, and we're going to practice using some of our formulas. So a DVD disc has a diameter of 12 centimeters and a rotational period of 0.100 seconds. Here we're going to determine the acceleration at the outer edge of the disc. So what I'm going to do first is I'm actually going to write down my information of what I have to work with. So here I have 12.0 centimeters. That there is my diameter. And so remember, when we're working with any type of circular motion, we always want that radius. So what we can do is we can take this diameter and divide it by 2. And we will get that radius. So 12 divided by 2 is going to be 6. And we have to make sure we account for our sig figs. So here we have 3 sig figs. So we have to continue with 3 sig figs. So add a decimal, 00 at the end. The next thing that we have to do as well is, if you guys remember at the, just a minute or two ago, I said that our units need to be in meters for our radius. So we also need to convert the centimeters into meters. So to do that, when we're working with centimeters going to meters, we're actually going to divide by 100. So our value is going to look like it's getting smaller. So then we should get 0.0600 meters as our answer for our radius. So then the next thing here that we're given is we're given the rotational period of 0.100 seconds. So that there is that capital T as your variable there. So what we're trying to find here is this centripetal acceleration. So if you guys remember your equation for centripetal acceleration that I just gave you a few moments ago, that is equal to v squared divided by r. So we have our radius, but we don't have our speed. But one thing that is awesome, and we can even scroll back up, we can use this speed equation that I just wrote above here to find that rotational speed. Because we have the radius and we were given the period as well. So this is actually a multiple step question. So step number 1 is we're going to find the rotational speed. So that's using V is equal to 2 pi r divided by your period. So if you plug in your values into your formula, you have V is equal to, so it's 2 times pi times your radius, which is 0.600, and then divide that by that period, which we know is 0.100. So go ahead and plug all that into your calculator. Just make sure, be very careful with how you're punching it in. So I'm going to go 2 times pi, and make sure you use the actual pi button, not the rounded value, and then times 0.600, and then divided by 0.100. You can do it all in one step, and what we should get in our calculator, and this will be a rounded value, we have 3.7699. And I'm going to account for sig figs here. And so here, when we're working with multiplying and dividing, we just have to look at the number of sig figs of each value. So 0.600 has 3 sig figs, and 0.100 also has 3 sig figs. And so usually what we'll do is we go to the number, or like the least number of sig figs, and in this case here they're the same, so we will go to 3 sig figs here as well. So now that we have the rotational speed, now we can go ahead and find that centripetal acceleration. So it's going to be our speed squared, so 3.7699 squared, divided by that radius, which was 0.0600. Once again, you can plug that all into your calculator all in one step. So go 3.7699 squared, then divide by 0.0600. What you should find is that you should get 236.869 in your calculator. And as always, we have to worry about our sig figs here. So this rotational speed here had 3 sig figs. Our radius had 3 sig figs, so our answer is also going to have 3 sig figs. So your centripetal acceleration is equal to 237. And in terms of our units here, we're working with meters and seconds here, so our acceleration is going to be meters per second squared. Then just to finish off the question, we are going to write a sentence. So we could say the centripetal acceleration is 237 meters per second squared. Alright, and so before moving on, I am going to end the video here. We're going to pick up the rest of this lesson in the next video.